Hello. So today's lesson 2.5, we're talking about factoring special cases. All right. Fundamentally, these are still quadratics. All right. And the goal is still to take standard form. We are factoring. So our goal is to still take ax squared plus bx plus c, factor it, and get it into the form where you have brackets, okay? And we'll see today that you might not always get two brackets, all right? There might be a situation where you actually get the same bracket twice, and you can just write it with a squared up here because it'd be the same thing being multiplied. And we'll see that in a second, okay? But big picture, we are still factoring. We are still taking standard form and putting it into factored form. Special cases, all right? It's not like anything is different about the quadratic. It's just that these rules, these methods that we're going to teach today are just a faster way than everything we've seen before to get it into factored form. All right, so let's look about the first one right here. We're going to be talking about difference of squares. And how do you recognize a difference of squares? Well, let's use this example that they give us right here. X squared minus 144. So looking at just the words used in difference of squares, well, the key thing being difference right here, well, notice how you have a subtraction right here. That subtraction, if you were just to say this, it's like you saying, what is the difference between x squared and 144? But specifically, these x squared and 144, they are both squares. The x squared is a little more obvious, but when you say something put to the power of 2, putting something to the power of 2 is like you squaring it, right? Squaring. Well, how do you get 144? Well, that comes from taking 12 and squaring it. So this can also be seen as x squared minus 12 squared. So you have a difference of squares. All right. Well, now what do we do with that? We get this x squared minus 144. All right. So you see this on a test. You're like, okay, well, this is my quadratic. Well, look above here. We have a nice formula for you. And what the formula says is you take the square root. All right, notice this x right here. This is x to the power of 1. So how did we get that? Well, that came from taking the square root of the first term. X, square root of x squared is x. So that goes in that first one. Then you just write a plus in the first one, a minus sign in the second, and the thing that goes next is just the square root of whatever's on the backside. So in this case, it's y squared in this formula. So the square root of y squared is y. So y goes there, and a y goes there. So let's apply this formula. So we know we're going to get two brackets, and inside of those two brackets, there will be a plus in one of them and a minus in the other. Well, what goes in front is the square root of this first term. So the square root of x squared is x. So there you put an x, and there you put an x. Well, what is the square root of 144? That would be 12. So then a 12 would go here. And there you go. That's factored form. So with just a little practice of knowing your square roots and stuff and being able to recognize it, you can get into this form much quicker than what we've seen before. Sorry, this form. When I say this form, I mean factored form. This is still factored form. And you're just using another tool. Like decomposition is a tool used to get into factored form. Difference of squares is a tool used to go from standard. This is technically standard. This is standard with a ax squared, that's the x squared in front, but the b value is 0 in this case. That's why you don't see a middle term there, minus 144. So that is standard form. So you're factoring using difference of squares to get into factored form. So let's look at some more examples. So factor the following. And note to always check for common factors, okay? Because at first glance, it might not be a difference of squares. You might have to take out the greatest common factor to then turn it into a difference of squares. And I'm going to kind of jump ahead here. We'll see that in this example right here, okay? Because notice how 50 is not a square root, or a square, sorry, and 72 is not a square. But your first instinct to notice whether or not something is a difference of squares, all right, it's kind of like this math survival guide, is like, oh, I'm dealing with a quadratic, but this quadratic only has 2 terms, all right? So that's the first thing, like, oh, well, I'm looking at something with 2 terms. And the next thing is notice that there is a negative in here. So if you see 2 terms and a negative between 2 terms, like this like light bulb should be going off being like, oh, this is probably a difference of squares. But let's check. All right, well, is x squared a square? Well, yes. The x squared, the square root of that, would give you x. So that is a square root. Well, is 81 a square? Also, yes, because the square root of 81 is 9. So we know this is a difference of squares. So let's apply our formula. So we're going to get 2 brackets. And inside the brackets, there's going to be a positive and a negative. They're going to alternate signs. And then what goes in the first numbers? Well, the square root of the first term. So we've already done the math right here. So that would be x. So an x goes here and an x goes here. And then the thing that goes after that plus and that negative is the square root of the second term. So in this case, we also did the math. It is 9. So a 9 would go here and a 9 would go there. And there you go. That is factored form. Okay, so try it again here. 4x squared minus 49. That is a difference of squares because 4x, we'll do our math over here. And with this one, the only difference that we're seeing here between all the other examples we've done so far is that we have this a value here. A is technically 4. So when you're looking whether or not something is a difference of squares, you need to include both the number, all right? So in this case, it is 4, and you need to include the variable, x squared. So when you take the square root of a number and a variable, you take the square root of both the number and the variable. So in this case, you would get 2, because the square root of 4 is 2, and the square root of x squared is x. Over here, the square root of 49, all right, the square root of 49 is 7. So we know this is a difference of squares because there's a negative here, and both the 4x squared and the 49 are squares, so difference of squares. So this would be 2 brackets. There is a positive and a negative between them. And then you just write the square, the square roots of each. So we've already done the math of the square root of 4x. So that was 2x. And then you have plus 7, 2x, minus 7. All right? Pretty straightforward. Let's do a couple more though. And in this case right here, we need to check for a common factor. So, so look at this and say, all right, what can I do? How can I turn this into a difference of squares? Or what is my greatest common factor here? Or common factor? Well, knowing your squares, all right, so knowing your squares, and when I say squares, it's like 4, 9, blah, blanking here for a second. 9, 16, 25, 36, right? Going up the list and just saying, okay, well, what are my squares? How can I turn this into a difference of squares? Well, if I factor out a 2 first, a common factor of 2, all right, so pull out a 2 from there, you would get 25x squared, 25 is a square, minus 36. 36 is a square. Well, what are those squares? Well, you get the square root. Let me just write the next line. 2 brackets. Well, what are these squares? Well, the square root of 36 is 6. The square root of 25, remember, x squared, you put the whole first term, is 5x. So the square root of this one goes right here, 5x. The square root of the back one goes right here, 6. And that happens also in the other bracket, so 5x and 6. And then you just put alternating signs. And there you go. That is a difference of squares. With the only difference here, using this word difference all the time, is that we had to common factor this 2 out. So always be on the lookout for that, okay? Ooh, another trickier one. Is this a difference of squares? Well, the back number might be a little more obvious, because if I take the square root of this, I get 4. But is the first term a difference of squares? It might not always be. You might see 2 terms with a negative. It might not always be a difference of squares. But in this case, x to the power 4 is a difference of squares. Because how do you get, all right, when you take, well, let's show you x to the 4. You're going to get x squared, okay? But let's think about it. Why? Why is x to the 4, taking the square root of that, giving you x squared? Well, remember what this operation means right here. The question, when you take the square root of something, you're saying, well, what 2 numbers that are the exact same gives me what's under the square root here? So x4. Well, what 2 numbers being exactly the same? Well, the only way to get x to the 4, and if these are exactly the same, is if this was x to the 2 and x to the 2. Because when you multiply variables, remember, you add exponents. So x2 plus 2 is 4, and therefore x to the 4 is x to the 4. So this indeed is a square root. So we've identified this to be a difference of squares, with our difference of squares being, okay, so write it out. You have in the first bracket the x squared, which is the square root of x to the 4. You add the square root of the last one, so 4. And then you have x squared minus 4. Okay, there you go. But if you're like, had this check and be like, oh, wait, there's also another difference of squares right here. And that is a common trick, okay? Whenever you see an exponent here, that is not 2, so not 2 when you're looking at difference of squares. Kind of, again, have this like, this light bulb go off, be like, oh, okay, there's probably going to be some sort of trick in here. And the trick is that you're going to have to do the difference of squares 2 times, okay? Because again, you have this also being a difference of squares. So you have the first solution, which is this x squared, or factor, x squared, I'll just write it plus 4. Write it on black because I was changing. And then on the back side there, you have a difference of squares. And let's see if we can do it a little faster, okay? Because that's a goal. With doing difference of squares, you want to get a little, the whole purpose is to get faster doing it. Oh, there goes my dog barking. So, applying a difference of squares here, well, we can see x squared and 4 are difference of squares. Well, the square root of x is x, and then you put a plus 2, x minus 2, right? The square root goes here, and the square root of this one goes here, and here. And that is now your final answer. Okay, so we've seen difference of squares, and now we're going to be looking at something called perfect square trinomial. All right, and this is where the final product, or the final answer, is going to be a bracket that looks like this. And recall what this is. Well, x plus y to the power of 2 in a bracket is the same thing as you writing x plus y, x plus y. Because these are being multiplied, and there are 2 of them, well, that's the same thing as saying x plus y squared, okay? And that's where that square comes from, because we haven't seen that yet. And when you have that as a final product, well, that comes from dealing with a perfect square trinomial. Well, how do you recognize a perfect square? So just as we did in the previous problem, let's use the example that they gave us here. All right, so we have this quadratic expression. So what makes this a perfect square? Well, we're using this word square again, okay? Just like in the previous one, we had difference of squares. Well, this one is not a difference of squares because you can clearly see there's no negatives here. And also there's 3 terms. There's 3 terms. But the key thing here being that square that we're talking about, this square. Well, where does that come into play? Is you still look at the first and the last term. So you say, okay, well, x squared. Well, if I take the square root of this, again, that's x. Well, the back one, the square root of 9, that gives us 3. So if the first and the last term, so if the first and the last term, if you have the ability to take the square root of them, that's the first step in checking. Okay, so the first step is saying, cool, those are both squares. The next thing that has to happen, okay, so the second step is you have to take those squares, roots, so in this case it is a 3 and an x. If you take that 3 and you multiply that x, and if you multiply it by 2, what do you get? If you get, I'll just write it shorter, if it equals the b of x, the b value, then it is a perfect square. Therefore, perfect square trinomial. So 3x times 2, what do we get? Well, if you do all that, you get 6x. And notice how this 6x is the same as this 6x right here. So it is a perfect square trinomial. So once you have identified it to be a perfect square trinomial, okay, so let's write a more formal way or thing. Both ax squared and c need to be squares. As we've shown in that step 1. And then step 2, taking the square root of whatever that a is, or a of x, sorry. A of x and multiplying that by the square root of whatever the c is, because you've already told me that they're squares, and then if you multiply that by 2, it needs to equal b of x, okay? Both of these things need to be true for it to be a perfect square and to apply this formula. So we have identified this. We have identified x squared plus 6x to be a perfect square. So now, what does the formula say? Well, the formula says, well, let's look right up here. Here is our x. Here is our x in our answer. Here is the y, and here is the y. So what do? Well, you have one bracket, because our final answer is one bracket of the square. So I'll do this in different colors so it's easier to contrast. Your final answer is going to be a single bracket with a square. Whatever the sign is on the b term, that goes here. So if this was a negative, this would be a negative. But in this case, it's a positive, so we put a positive here. And then what goes right here is the square root of whatever that is. So in this case, it's x. So we put an x there. And then whatever goes here, this is the square root of the back one. So in that case, it's 3. So you put a 3 there. So let's see more practice, okay? But that is the formula. And it's much faster, okay, than doing decomposition. That's the purpose of teaching this. It's a more efficient way of going about it. So, example 2, factor the following. Well, I see 3 terms, all right? This could be a complex trinomial because here the a doesn't equal 1, but I can't factor a 4 out from all of these terms. So it is a complex trinomial, but it's a special case of a complex trinomial. And that's because 4x squared is a square. You'll get 2x. Just like 9 is also a square. You'll get 3. And now if you take those two values, if you take 2x and if you multiply it by 3 and then multiply it by 2, what do we get? Well, that would give us, so in this case, 6. 6 times 2x will give us 6. And then 6 times 2x, you'll get 12x. And this equals this. So therefore, a perfect square trinomial. So you just apply your formula now. The formula says, well, whatever the sign is right here, that goes in the middle. And then you just put your square root of the first term. So in this case, it's 2x. And then you put the square root of the last one. So in that case, it was 3. So 2x plus 3. And then don't forget, because if you don't put this square up top here, so if you forget that, well then right now you're not dealing with a quadratic. All right? You started with a quadratic, but then you ended with a linear if you forgot to put that square there. So you've actually changed the whole thing. So do not forget to put that 2 up top here, okay? So there is factored form. Let's look at B. Is this a perfect square trinomial? Go through your checklist. So step 1, check. Is the square root of 9x squared a square? Yes. You're going to get 3x. Is the square root of 4 a square? Is 4 a square? Yes. It's 2. And then what happens when you take 3x, multiply it by 2, and then multiply it by that other 2? Well, in this case, you'll get 4 times 3x. You'll get 12x. And once again, yes, this and this are the same. So apply your formula. So, in this case, the square root of the first term was 3x. here I see a positive, so I'm going to put a positive. And then I have the square root of my last term, 2. And then the whole thing is put to the power of 2. All right, and there you go. There's your final answer. So see how this is much quicker if you go back to the previous lessons where we did complex and trinomial? Like, yes, you have this setup right here, but with practice, you'll just come to quickly identify it. And then you can just jump to this step right here. Jump to this step. But again, it just takes practice to do that. So let's look over here. Are we dealing with a perfect square? Well, check. Take the square root of 3x squared. Well, no, that's not going to give you a solution. Because the square root of 3 is not a nice clean number. It's like 1.7 or something. Oh, so that doesn't work. So right off the bat, you already know it's not a perfect square because this is a 12 right here. And you can't take the square root of 12. But there was a step that came first. Remember, check for common factors first. Okay? So if I look here, well, a common factor, well, this is divisible by 3, this is divisible by 3, and so is this. So that means I can pull a 3 out, and I'd be left with x squared plus 4x plus 4. All right. Well, is this now a difference of squares, or perfect square trinomial, sorry? Yes, because this right here, the square root of x squared is x, and the square root of 4 is 2. And if you take those two numbers, x, multiply it by 2, and then multiply it by this extra 2 that's required in the formula, you would get 4x, which is the same thing right here. So then your answer is equals, don't forget you factored out a 3, so 3 is still there, but then you have your brackets, and they're squared. This right here is a positive on the middle term, so a positive goes here. And then you have the square of the first term, so x, and the square of the second term, plus 2. And there's your final answer. 3 brackets x plus 2 squared. That is factored form for that C. Okay, next one. Ooh, something looks odd here. It's written in a weird format where this is my C, and then this is my ax squared, and this is my minus bx. So I don't like that. Let's rearrange it, all right? So let's just put it in ax squared minus bx plus c format. So it would actually be x squared minus 10x plus 25. And now let's factor it, okay? Once we put it into proper form. So rearrange. All right, do your check. Is x squared a square? Yes. Is 25 a square? Yes, it's 5. Does 5 times x times 2 give you your middle term? Well, that gives us 10x. And yes, 10x. And here I see 10x. But notice that this 10x right here has a negative. So nothing changes so far, right? You've identified this to be a perfect square. So the formula still applies where you take your brackets, or your final answer is going to be in brackets with a square, where in the first, you're going to put the square of the square root of the first term. And on the back side, you're going to put the square root of the last term. But remember, whatever sign you see here, that is what goes here. So in this case, as opposed to all the other ones, where they were all positives, and positive, that's because this was positive, positive, and positive. Well, in this case, this 10 here is a negative, and that's why we put a negative there. So like I said, this does just take practice. So there is a lot of practice problems for you to go through. You don't just have to stop with these. These are just recommended. but I'll see you in class.